Okay, good day, grade 8 students. So we continue on our topic about polygons, and then we have this topic. First one is on naming a polygon. So a polygon has different names. So we name a polygon based on the number of sides that it has. And the naming system for a polygon is very unique. It has a very systematic and an organized way of naming the different kinds of polygons based on its sides. And they mostly stem from Greek terms, Greek suffixes that we use in terms of naming these different types of polygons. So the first one is a monogon. Okay, from the word mono, meaning one, that means it's a polygon with one side. And it's not a possibility, of course. There's no in Euclidean geometry, a monogon is not an a real figure, because it's not recognized as a polygon. Okay, because that's only just one point. Okay, so you cannot create like a closed figure with just one point, but it is a figure in graph theory. So graph theory is kind of like a very advanced form of one of the advanced forms of geometry. And then we also have a digon. So a digon is not a polygon in itself in Euclidean geometry. So it's a polygon with 2 points. Okay, so that's also not a closed figure, but in spherical geometry or in other modern types of geometries, so it's a polygon because the 2 points can close themselves. And then we also have a triangle. So a triangle, of course, has 3 sides, so that's called a trigon or a trigon. Then we have a quadrilateral, so we also call that a tetragon, so it has 4 sides. And then we have the pentagon, 5 sides, hexagon, 6 sides, heptagon, 7 sides, octagon, 8 sides, nonagon or enneagon, 9 sides, decagon, 10 sides, hendecagon or undecagon, 11 sides, dodecagon or duodecagon, 12 sides, tridecagon or triskaidekagon, 13 sides, tetradecagon, 14 sides, pentadecagon, 15 sides, so on and so forth until you reach icosagon. So icosagon is 20 sides. Then icosakaitetragon is 24 sides. So later you'll discover how it became icosakaitetragon. Then we have also triacontagon, 30 sides, tetracontagon, 40 sides, pentacontagon, 50 sides, hexacontagon, 60 sides, heptacontagon, 70 sides, octacontagon, 80 sides, enneacontagon, 90 sides, hectagon, 100 sides, chiliagon, 1000 sides, myriagon, 10,000 sides, megagon, 1,000,000 sides, and the apeirogon, infinite sides. Okay, so we can name also a polygon using the term. Okay, wait, let me just use the pen tab. Okay, so we can also use this naming convention for polygons. So we can call them as an n-gon. Okay, so an n-gon meaning n, the number of sides. Okay, for example, you want to name the 24gon. Okay, so we can simply name a polygon with 24 sides as 24gon. But if you want it to sound a bit fancier or more scientific or more mathematical, you can call it as an icosakaitetragon. Okay, so we move forward. So how were those names formed? How did the icosakaitetragon name, how was it formed? Okay, so we use this convention for naming for polygons by using different suffixes and prefixes and infixes for the different types of polygons based on the based on the 10th digit that they have per 10, okay, per 10 places, and also per 1's digit places. For example, we have here a 20-sided polygon. So a 20-sided polygon is called an icosagon. Okay, so an icosagon has 20 sides, but if you want to name a 26-sided polygon, let's say for example you want to name a 26-sided polygon, well, you can simply use 26gon. But you can also use icosakai, so kai means end, icosakai and hexagon. Okay, so that's icosakai hexagon. So the more mathematical term for a 26-gon is an icosakai hexagon. Let's say, for example, you want to name a 99-sided polygon. So how do you do that? Well, you can use 99-gon. That's the simpler term. But if you want to make it sound more mathematical, okay, you can use enayakonta. Enayakonta, so that's the prefix for the 10th digit, and then we use the infix kai. Okay, enayakonta kai, then enyagon. Okay, so the 99-sided figure in a more mathematical sense is an enayakonta kai enyagon. Okay, so that's how you name it. Okay, so kind of sounds like a big giraffe or a big dinosaur that's going to eat you, but that's the main logic about it. So that's the naming pattern that we use. We use prefixes for the 10th digit, and we use the infix kai, and then we also use another infix, the ones digit hena, di, tri, tetra, and then we use the suffix gon. And then you create the name for the polygon that you want to create for 2 digits. Okay. For example, we have here a 39-gon. So how do you name a 39-gon? So you look at the table. So 30. Okay, so since that's 39, you start with 30. Triaconta. Okay, and then triaconta is of course followed by kai. So that's triaconta kai, and then find the 9-sided figure, the ones digit for that infix. Then we have that enya. Okay, so that's triaconta kai enyagon. Okay, so that means the 39-gon, its mathematical or more scientific sounding name is triaconta kai enyagon. Then we also have the 52-gon. So how do you name a 52-gon in geometry? So we do that by, again, looking at the table and then finding the 50th tens or the 50th place. So we have their pentaconta, and then we put the infix kai. So pentaconta kai, and then we find the ones name, the name for the ones place value. So we have their die. Okay, so we have now pentaconta kai digon. So that's the more scientific name for a 52-gon. So it's a pentaconta kai digon. For the 71-gon, we can have a heptaconta kai henagon. For a 91-gon, we can have an enayaconta kai henagon. And then for an 87-gon, we can have an octaconta kai heptagon. Okay, so that's how you name figures in geometry with sides that has 2 places.